Hey, welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. In this episode, we'll solve some AWS Solutions Architect Professional Certification questions. Friends, if you're new to the channel, please subscribe and click the notification bell icon for future updates. Let's solve our first question. You're designing multi-region architecture and you want to send users to a geographic location using latency-based routing. However, you also want to use weighted routing among resources within that region. Which of the below setups would best accomplish this requirement? So I would suggest you pause the video, take some time out to think about this question, and write answers in the comment section. The requirement is that we need to have a latency-based routing, but within the region we need to have a weighted routing. So let's look at the options. You will need to use complex routing or nested record set and ensure that you define latency-based routing first or latency-based records first. So looking at this option, the requirement is to have a latency-based routing at a geographic location level, and then you have a regional routing for a weighted routing policy that you want to apply within that region. So option A is not fulfilling it because we are having a latency-based routing first. And what will happen is this latency-based routing will be applied as a child routing or nested route. So we cannot have a latency-based routing. In this case, we need to have a weighted routing first before we can have a top-level record that is set as a latency-based routing. Okay, let's look at the second option. You will need to use complex routing, nested record set again, and ensure that you define weighted routing or weighted resource record first. So what we are doing is we are saying we are going to have a weighted record set, and then we'll have a latency based. So weighted will be applied for the regional, and then this will be global. So this looks like a possible answer. Let's look at other options also. This cannot be done. You can't use different routing records together. So this is not possible. You can create nested record set, and so you can accomplish that using nested record set. So this is not an option. The fourth option over here is you will need to use 4 times A IPv6 addresses when you define your weighted base record set. So there is no such requirement. We don't need to have IPv6 for this configuration. So this is again a wrong option here. So the answer for this particular question is option B. Moving on to the next question. You recently hired as an AWS architect in a startup company. The company has developed an online photo sharing product. After the product was developed for a week, you have found that from time to time, the instances in the autoscaling group have reached the maximum value due to high CPU rate and traffic. The network team has identified 3 IPs. So basically you can see network team has identified 3 IP addresses that send large number of malicious requests during that time. You plan to configure a WAF, Web Application Firewall, Access Control List, ACL, with a rule to filter these IPs, these 3 IPs primarily, which component or service you are able to associate with the new Web Application Firewall ACL with. So you have to select 2 answers. Basically, the question is what all services can associate to a Web Application Firewall? Let's look at the options. The first option is the global CloudFront distribution. And if you have read about Web Application Firewall, the overall list of Web Application Firewall tells you that it can be associated with certain services, and global CloudFront distribution is one of them. So this is a correct answer. The autoscaling group that the product has used. Now, autoscaling group doesn't operate at a global level. It is a regional service, and that is the reason. And also, it is not associated directly with the Web Application Firewall. So there is no way to put that Web Application Firewall on ACL list on this. All EC2 instances created for the product add each instance ID to associate with the ACL. Again, EC2 instances are part of an auto-scaling group, but they are not global in nature, they are regional, they cannot be associated directly with the auto-scaling group. So this is not a correct answer. The application load balancer. Now the application load balancer is external facing, it's a public in nature, and it can be associated. So yes, this is the second option. The network load balancer. So it doesn't matter where the network load balancer is, but if you know the web application firewall, it is not supported. So this is not an answer. So what all things web application firewall can be associated with? One is CloudFront, application load balancer. You have API gateway, and there is one more service called AppSync. So these are the only four things that you have to keep in mind. It may change. So AppSync for your GraphQL APIs, and API gateway for your REST, any RESTful service that you have created, an application load balancer that fronts your origin server basically. Just keep in mind, and maybe there are more services in the future that can work with this, but just keep in mind these four services that support application to integrate with the WAF ACL. Moving on to the next question. The next question is about a user has set up autoscaling group with ELB on EC2 instances. The user wants to configure that whenever the CPU utilization is below 10%, autoscaling should remove one instance. How can you configure this? How the user can configure this? So please pause the video if you want to take some time. Just think about the answer, possible answer out of these four. And if you want to write it down in the comment section, you can just note it down before applying all the logic that you are thinking behind it. So let's look at the options. The user can get an email using SNS. So SNS is a notification service whenever the CPU utilization is less than 10%. And the user can use the desired capacity of the autoscaling to remove the instance. Now, this is incorrect because in order to get a notification, the user has to configure CloudWatch, which can trigger a notification to autoscaling group to terminate an instance. Updating the desired capacity will not work in this case. So this is not an option in this case. Use CloudWatch to monitor the data and autoscaling to remove the instance when using scheduled actions. Now, one thing about scheduled actions is it is only for scheduled duration. It is not running based on the desired capacity at any given point of time. It is only for a scheduled period of time. So if you have a scheduled action, primarily it will work scale up or down based on the schedule that you have set up. So this is incorrect in this case because it is in response to a predictable change that you have. So you have scheduled something for a predictable change, but in this case it is not like that. Configure a CloudWatch alarm to execute in the execute policy that notifies the autoscaling launch configuration. Keep in mind this is autoscaling launch configuration when the CPU utilization is less than 10%, and configure the autoscaling policy to remove the instance. Now in this case, the biggest catch is the launch configuration. Launch configuration is for launching a new instance. So this is incorrect because notifications should be sent to the autoscaling group and not the launch configuration. So this is again a wrong option here. Configure a CloudWatch alarm in the execute policy that notifies the autoscaling group when the CPU utilization is less than 10%, and configure the autoscaling policy to remove the instance. So this makes sense because the notification is sent to the autoscaling group, which then removes the instance from the running instances. So our answer is option D here for this question. Moving on to the next question. A company is creating a new recipe blog sharing application in AWS. The static content has been put into an S3 bucket. In the meantime, a database is needed to store the data for various blog posts. The application retrieves data from the database and dynamically renders a recipe blog page. The web application has a requirement to serve users globally. Also, the company prefers a serverless solution if possible. Which combination of services can be used together so that the application does not need origin infrastructure and administrative effort are required for autoscaling, backups, and database redundancy? Select three options. So the requirement here is there is some static content, there are some dynamic pages, and the company is looking for a serverless solution. They don't want to have automatic scaling, backups, and any kind of database replication of database. So in this case, let's look at the options that we have. Configure an elastic load balancer and autoscaling group to dynamically balance the traffic. First of all, ELB and autoscaling does not help the route traffic globally. So this is only regional. So this option is out of picture. Configure an AWS Cloud Front to serve end users from various edge locations. So if you have read about CloudFront, CloudFront has over 100 edge locations, and it is a proper CDN to deliver any kind of content to the end user using very low latency globally. So this one is one of the options. Create an auto-scaling configuration for EC2 instances to automatically scale up and down according to the load. Now again, this is with the same reason that we have auto-scaling group here. This is again not global. This is a local option. It's not a serverless option. They were looking for a serverless option. So that's why this is not a correct option. Option D is run the application code in Lambda at edge to retrieve data from database, and response is also cached and served by CloudFront. So in CloudFront, you can have Lambda at edge, which can be used for any kind of authorization or any kind of function that you want to run at the edge location. So this makes sense, and this is a viable option where we can use Lambda at edge to build a dynamic page, get the data, serve the static content from CloudFront, and it makes more sense with this option. The next one is use DynamoDB to store data for blog post that the application is using. Now the requirement is to store data in this, a database is needed. So DynamoDB gives you a good option. DynamoDB has global tables, which can automatically replicate your data globally and with low latency. Also, DynamoDB can scale based on the load. So you can have on-demand capacity, or you can even define capacity for read-write. Mostly it is very transparent from the end user, and you can always use this to scale as per your needs. So this is the third option. The fifth option here, for the dynamic data, including the blog post for the customer, configure an RDS instance as a database. The reason why RDS is wrong, because when you configure an RDS, you basically tell what kind of instance that you need to run your RDS, and obviously it is just local. That means it is regional, and in order to go global, you'll have to have two instances running in two different regions, and then you'll have to have a sync process, and it is not going to scale beyond a certain limit because your instance size is all predefined. So it's not as scalable as a DynamoDB, and that's the reason it is not one of our answers. A traditional IT company is actively migrating its existing on-premise servers to AWS and making big progress. Recently, in order to meet the internal regulatory requirements, backup policies and strategies are needed for its various AWS services. The company plans to use AWS Backup service as the central place to manage and automate backups, which AWS service can be managed by AWS Backup. Select 3. Now the requirement is to choose 3 services that can use AWS Backup. Let's look at the option. Before we go into these options, if you want to pause the video and select the correct options and put them in comments. AWS Backup is a central place to set up backup policies and monitor backup activities for AWS resources, including Amazon EBS volumes, Amazon RDS databases, DynamoDB tables, EFS file systems, or AWS storage gateways, storage gateway volumes. So let's look at the options. AWS RDS MariaDB instance. Now in this case, MariaDB instance. Now this is correct because all RDS, AWS RDS types are supported except Amazon Aurora. Let's look at the second one, S3 bucket. Now S3 bucket is a highly scalable, reliable service which does not need backups from AWS Backup service. And also you cannot take a backup using AWS Backup for S3 bucket. So this one is the wrong option here. AWS Redshift cluster. Now Redshift is a data warehousing solution, and it is not a supported service for AWS Backup. So this one is again wrong option. EC2 AMIs, EC2 AMIs that are created from running EC2 instances. AMIs are already stored in S3, which is not supported by the AWS Backup. So in this case, like, this is also a wrong option. Several EBS volumes, and these are not encrypted. EBS volumes can be saved as a snapshot, which can be managed by AWS Backup. So this is another option. AWS Storage Gateway Volume. Now you have a volume gateway in this case. AWS Storage Gateway is a storage service that enables the on-premise application to use AWS Cloud Storage. AWS Backup can integrate with AWS Storage Gateway and help design a hybrid backup plan for the service both in the cloud and on-prem. So this is our option. So we have option A, E, and F for this question. This is the end of the episode. Thank you for watching. If you like the video, please like, subscribe, and press the notification bell icon for future updates. This is your host, Bhavesh Kumar, signing off. Thank you.